So, hello participants. So, from my side, common welcome to all of you. We are in the midst of very busy academic year. I have not before. This workshop is restricted to a very small number of participants. Already, I don't think faculty, all faculty members of academy have any time at this time to even think of attending any event that we don't cancel classes for the sake of enabling anybody to participate in the event. So we are, therefore, we extended invitation to our sister institutions and people from Korea University to take the benefit of this workshop. So I request Professor Raghunath Rudran, Dean of Research at API, to speak. So it's a pleasure for me to welcome Dr. Karthikeya Abdullah, who's conducting this workshop on JASP. So we just learned it stands for Jeffrey's amazing statistics program. The full form of JASP. So like the program is just amazing. So professor is also amazing. So I have so he's the backbone of the analytics department. Yes, not for many years now, the information system and analytics area. And every year he takes amazing number of classes. As far as, so I don't know, every year we must be crossing 300, 400. I've stopped counting since many years. And also he is very oriented towards giving the FDPs actually. So we from the research team. So this is the technically the fifth research day. Starting, we had 3 last year, last academic year. Yeah. So we had 3 in the last academic year, starting with a general one with Mahe, and where we invited all the scholars. We had invited Yelakoya and other people. And I think the second one were more specialized. We have called distinguished scholars such as Dr. P. Murugan for converting the papers. The third one, I think Dr. Ben Bahadur Singh. Of course, and then we followed up with fourth one. Unfortunately, we could not call them again, or they had other commitments. And however, we don't want to lose the tempo. So we'll keep it up in the sense of the research base. And Dr. Karthikeya had stepped in and said, so there's a capability building. So skills building of JASP, that is the thing. About the pitching templates and all, we hope to carry it forward whenever Morgan and they are available. Dr. Jang Bahadur are available. We are working on their availability also. Meanwhile, we will keep on this, and I hope that you will have a very 2 fruitful days. And I'm hoping that more participants will trickle in. But anyway, whoever there, I think you can. I hand over the floor to Dr. Karthikeya and a very full thank to all of you. Thank you.
Thank you. Thank you so much. Yeah. Yes, good morning, everyone. I think it would be better if those who are in back can come in front, occupy the front seats as much as possible. Okay. Not to make you feel that it's a filled room, right? That you may have a better audio from my side. Although I can speak, my voice box is so the way that it could even surpass this building. All right. I hope all of you have got the material. Now that material is for reference purpose only. It doesn't have any commercial value. Okay. So because there is nothing about JASP in that material. Okay. It is only to facilitate ease while solving the problem, right? So we have some problem sheets and thereby those problem sheets, you have to fill in some values. So it would be easier for you to look at the book and fill out the values rather than taking from the screen, because the same material is available also, but it would be easy for you to refer the manual, right? And there are some academic notes on that. Okay, but then that also is something which doesn't have much of the commercial value because it just very briefly put up. Okay, so I don't mind if it goes for sale also, right? Right. Right. So thank you for coming here for this workshop and believing in something, some takeaway from this workshop. Okay. Now, what essentially we would be doing here is because um, since you're coming from various backgrounds, I assume that you have zero knowledge of statistics, right? And but then I need to keep it in pace because otherwise we may just cover the basics of statistics at all, right? So so that's not the idea, because I'm trying to even crunch what we generally cover in a statistics program clubbed with even business research methods, right? So it's a Herculean task. So we will see how we can go about it. Right. So now let me tell you something about JASP. Now, why JASP? Now, some of you might have got used to it or been trained in the so-called SPSS, right? So now SPSS, of course, that was probably the only statistical software for a long time, in the sense that people just got used to it. So anything the statistical analysis, SPSS is the sounding word. No, just like we talk about chocolate means Cadbury's, right? So statistics means SPSS. So that's what was the idea. But then now, uh, over the years, a lot of open source softwares have got developed, okay, based on open source languages. Okay. Now, one of these is JASP. Okay, so JASP has been there for at least, to the best of my knowledge, for last 10 years or so. Okay, so I started using JASP when it was 0.14.1, but right now you see that it is 19%. Yeah, 19.3. So it has upgraded to that version. Of course, that time also it was a good software. It had an upper hand over SPSS. I'll tell you why in a short while. But yeah, so there is a lot of improvements which have happened over the years. In fact, I have used this software even in my statistical classes, because like I cannot comment on statistics courses taken by other faculty members, but at least in my course, I used to take up this as the core software over even Excel, because Excel was, I never considered Excel as a statistical software. It was just a spreadsheet software. Okay. In fact, to be frank, on statistical grounds, I hate Excel because it just uh, is focused on how we can get some output. Okay, but it doesn't follow a statistics philosophy. Okay, so that's the reason I switched to JASP, and also I could take up statistics classes, and even for that matter, the business research method classes using this particular software. Okay, right. So it is free. So the first thing I like about is, and I always like free food and free software. Right. So and since it is free, so I can easily conduct workshops, right? So otherwise, always we had asked the other concern that do you have license, right? So that's the, so it's an open source software and it's a very intuitive interface. Now, intuitive interface in the sense that unlike, like if I compare with SPSS, in SPSS you need to fix up your model and then you see the output later on after pressing OK, right? But whereas this is something where you can even do what if analysis as and when you are building the model. So it gets started as and when you just initiate that technique, right? So it's a kind of an instant gratification, right? So that's why it has an upper hand. Now, of course, to be frank, though JASP provides you like those who are hardcore statisticians, they may also adopt Bayesian approach to statistics, something which I am not familiar. But then most of us use the classical approach to statistics. Like that's the only thing I know basically. So I believe that that would be only useful here. So I'm not covering the Bayesian aspect of the statistics here. Okay. But it has provided this classical and Bayesian approach for different types of tests, as we can see there later on. All right. So this is about the software in general. And as we progress, we will also see some of the features of JASP, which will help us to ease out even our how to place our analysis output, maybe in a research document. So, so there also we'll see how this will be very useful and what are the different features which are enabled out here. Right. Now, again, the one cautionary thing which always used to happen while teaching the course on statistics was the there was no software. Okay, maybe apart from Excel that time, wherein you can work on a statistics itself, in the sense that let's say you have the statistics information, that means summarized information. You do not have the data set with you. You only have the summarized information about some analysis which has been already done on a data set. And based on that, most of the time you have to do some tests. Okay, like for instance, instead of giving you a data set, if only mean and standard deviation of the data set is provided, right? Then most often you'll be told to do some statistical tests based on the information which is given in the problem, right? So that was always a problem in terms of which software would be ideal, wherein you can even work on the summarized information and then carry out the statistics. Okay. Now that resulted in, of course, when statistics course itself was developed, they started giving a lot of formula, like for calculating these particular statistics, this is the formula. For calculating these particular statistics, this is the formula. But there were a lot of formulas, and that inherently made the students shy away from that course. Because ultimately what happened, like you need, it became a test of memory, right? You need to memorize the statistics formula, like for the key statistic, this is the formula. For chi-square statistics, so most of the time, students used to spend only in computing rather than analyzing the output. Okay. So I was trying to figure out a way that what can make this ease out from the student's perspective, in the sense that they don't have to remember any formula for that matter. Okay, maybe one or two simple formulas which it's easy to recall by practice. Okay, rather than thumping on them that okay, if most of the time you spend out of 10 minutes on that problem, you spend 8 minutes only computing the problem part, right? So that's where the challenge was while teaching statistics course. Okay. Though up to some extent that problem was eased out by giving some tables, right? So the statistical tables were given to the students. Okay, you don't have to, but those tables were ultimately useless because again, there also you need to follow some procedures and so on. Now, the good part of a statistics software is that if you have a data set, then you can get your statistics automatically. You don't need to uh, calculate the statistics. So this gave me a new idea, and this is what I'm going to show you today. Something which is never thought of, at least to best of my knowledge, in any statistics course, probably by any statistics faculty. Okay, is what if for even a summarized problem, what if we can generate the data set exactly to the nature of the problem and simply post it in a statistical software, I can get the results with ease. All that the student has to know is which test has to be applied under what circumstances, right? So that is what I was trying to figure out. Is there a way out for this? Okay. Now, to begin with, let's start with please take your handbook. And in this, let me begin my session on t-tests. So there is a A1 session on t-tests. Okay. So these are the typical problems which are there in your in a business statistics course. Okay. Right. Business statistics course. Wherein, of course, students have to know that it's a t-test problem. Of course, now I've given to you that it is a t-test problem, so have it. Okay. That is one thing. Other than that, they had to do some calculation of statistics. Okay. And then ultimately, if they have time, they can interpret. Okay. So most of the stress was on. So even from the answer key perspective, there was a lot of emphasis on calculation. Like out of 10 marks problem, let's say the first question it was of 10 marks problem, and then you say that okay, 8 marks is only for the computation part. 2 marks is for analysis or conclusions, whatever you do. Right? Actually, it is very outrageous. Right? Where we are starting with and where we are ending, right there. So, if you see the first problem itself, right? Let's have a look at the first problem. A student believes that the average grade on the statistics final examination, okay, you can just refer to the day one, all of you on the same page, day one session on t-test, 9:30 a.m. to 11 a.m. Okay, so the question is there, the first question itself. Okay. A student believes that the average grade on the statistics final examination was 87. A sample of 36 final examinations was taken. The average grade in this sample was 83.96 with a standard deviation of 12. Okay. Right. Now let's first understand this problem itself and see what are the things which are given here as like information. Right. It believes that the average grade on the statistics final examination was 87. Now, generally, when we talk about statistics, especially inferential statistics, okay, we are talking about a population, right? So all the inferences are about population, right? So here, a student believes that the average grade on the statistics final examination was 87. Now, it is a belief that on an average, that in any statistics final examination, it is 87 is the average grade. So grade here refers to marks. Okay. A sample of 36 final examinations were taken. Now, so what he believed is what we generally consider as something about the population, right? So that means the hypothesized mean in this concern would be, so we generally say hypothesized mean as mu h naught or other y h naught. Okay, now this I always used to make fun in statistics course when I introduce this concept of hypothesis. Perhaps you might try. So I used to say, okay, we have a ho-ha here. Okay, ho. Okay. Now, and most of the time, there is also still it would be a confusion even among researchers. Okay, what is the null hypothesis and what is the alternate hypothesis? That is always even among the researchers, not only among the students, but even among the researchers, they have always a confusion about what to report. What to report in a research paper? Should we report our null hypothesis or should we report a alternate hypothesis? So the naive researchers will report both. They'll report even null. So I've seen some research papers where they write both null and alternate because they were taught in that way in probably in a research methodology class, right? So there is a set of hypotheses which is always there. So it's a set, okay, right? So now, first of all, why something is called a null and why something is called an alternate, right? So again, how do you say that something is null and something is alternate? So I devised this mechanism, like I always used to say this as Guru Mantra. Okay, that is the three perspectives of null hypothesis. So if you understand any one of these perspectives is applicable in that situation, then it is a null hypothesis. Otherwise, it is a alternate hypothesis. Let's see the first perspective. The first perspective, what I say is the equal to perspective, right? So equal to perspective comes. Now, what I mean by equal to perspective, that means anytime if you are doing any kind of a test based on the parameters of the population, like it could be mean, it could be population, it could be standard deviation. Okay, any test based on the parameter of the population, the limiting value is always associated with null hypothesis. Like for instance, here, when we say a student believes that the average grade on the statistics final examination was for 87, right? It basically means that the student is believing that in a population of the examinations which are conducted, the mean value of any person getting marks or the average value of the marks is 87. Now here he is very clear about his belief that it has to be 87. Okay. So anytime there is a limiting value, that has to be in null hypothesis. So when we are writing here, we generally designate, okay, say if I'm testing for mean, we generally say mu is population mean, okay, and say x bar is sample mean, okay. Mu is a population mean and x bar is a sample mean. So we never hypothesize for sample because there's nothing to hypothesize about sample. It has to be always about population. The sample is observed. Okay, so why you have to make a theory out of something which is observed, right? So this here in this case it will be mu equal to 87. So this is one perspective you can see, right? That is the equal to perspective. Let's look at another perspective for the same problem. Let's say the other perspective is the status quo perspective. The other perspective is the status quo perspective. Status quo means what is currently existing. Okay. What is currently existing. Okay. That's where I used to use that term because in Marathi, I think ho means yes, no? Ho. Right? What is currently existing? Ho, like 87, ho, right? So the mu equal to 87, yes, now currently the average is 87. Okay, that is the belief. You are believing that currently this is the practice, right? Now, if you don't believe in the status quo, you have to give sample evidence. That means if you want to defy from what is believed, okay, then you need to give evidence, right? So if I say that somebody is like everyone considers someone as God, okay, and if I have to say that no, he is not God, he is an idiot, then I need to give them enough evidence to prove that that person is an idiot. Otherwise, I have to believe that he is God. Right? So that means that anything where you have to prove, which is not the current status, that means you need to prove that, okay, or rather you have to disprove that particular status quo. That becomes your alternate hypothesis. That's where you collect statistical evidence and others. Right? So obviously here with one perspective I got mu equal to 87. Even the status quo perspective also, that is the current belief what the student has. So it is 87. But if I say no, the other student says, hey, your belief is wrong. Your belief is wrong. It is not 87. Then that is where we do alternate hypothesis. Now there is third perspective, but it may not be understood well here. I'll come to that when it comes. But right now, let's stick to these two perspectives of null hypothesis. So the null hypothesis satisfies the condition of a limiting value that is equal to perspective. And the null hypothesis always talks about the current status quo or status of a situation. Okay, so this is how you identify, and both of these are consistent with each other. Okay, in both perspectives which I have talked about, they are consistent with each other. You cannot say that in one perspective I think that it is an alternate, and another it won't happen. It won't be consistent. So the limiting value and the status quo both lead to the same conclusion, that whether it is a null hypothesis or not. Okay. Because on the other side, if alternate hypothesis doesn't take any equality stance, it has to take, so alternate hypothesis cannot be dubious. Okay. ये भी हो सकता है, वो भी हो सकता नहीं. You need to take a stance there. Okay. Take a stance and then provide the evidence. Okay. That's the reason in alternate hypothesis you never get an equal to sign. Either it will be not equal to, or it could be less than or greater than. Okay. I hope that's clear. Okay. Now that we understood what is this 87, now here somebody tried to defy this person, saying that sorry boss, you are not right. Your average grade may not be 87. So somebody wanted to check the belief system whether it is actually in practice. So a sample of 36 final examinations was taken. Some sample observations were taken. So now you know that there is a data set where there is sample size is 36. So we say n equal to 36. Sample size is 36. Okay, that means I have a data set which is talking about my grade. So grade is the variable name. Okay, I have 36 observations in that sample. So 36 is my sample size, and it happens to be, okay, it happens to be how much? The average grade in the sample was 83.96. So my X bar in that sample of 36 is 83.96 and standard deviation of 12. Now this standard deviation refers to the sample standard deviation, right? So they generally denote sample standard deviation as S. Okay, because there is population standard deviation, we call it as sigma. This is just to differentiate that what is for population and what is for sample. Okay. So S becomes 12. Okay. Now this is how the student also will formulate the problem. Okay, this part they will write. Okay. Now after this, then they have to say that which test they have to carry out. Right. And in that test part, they have to compute. Okay. Let's say they identify this. Now this is a case of a one sample t-test, because we are trying to see whether the sample evidence defies the null hypothesis or not. That means, is that sample evidence good enough to reject the null hypothesis? The sample evidence good enough to reject the null hypothesis. Now comes the question of, okay, t statistics. Anybody remembers t statistics formula? Probably not. Right? And this might be easier because it's one sample, but when it comes to two samples, multiple samples, then it becomes tougher as you go further. Right? Now this is where my technique will come into picture, which will capitalize using JASP. So what I'm going to do is, okay, no rocket science, but rather just make my life easy by creating the data set, which is easier compared to remembering the formula. Okay. Now creating the data set, so it's kind of simulation. It's creating the data set with the same characteristics what you have placed here. Okay, and that's where my trick worked. And apparently this particular approach was most welcomed by the students, and it was very easy. Like, okay, you create the data set, straight away use the test this, and it will automatically come, and I can write within 5 minutes done. Okay, the only thing what they need to know is how to interpret the result and how to, first of all, what test has to be applied. Okay. Otherwise, so that means there is a lot of mental stress which has been rolled out. Okay, remembering formula is always a headache, right? Okay, so first what we'll do is we'll see this trick, how to create this data set in JASP and immediately do the analysis. Okay, now there is an option here called new data. All of you have opened this interface. Please come to this page. So, have you come to this interface? Yeah. Now click on this new data. Just click on this new data. Okay. So now what we are going to do? We are going to have the data set of 36. Right? I'm going to create a data set of sample size 36. So the first thing what I need to do is first resize the data. That means I need to click on this resize data. Resize data. So how many rows I should have? I should have 36. So, and since I have the only variable here is grade. The only variable grade here is grade, right? So column is 1. The number of rows that becomes 36. Okay. And you click on resize. Okay. Now once you have resized, you see all dot things have come, right? For how many places? 36 places, exactly 36 places, you will get dot. Otherwise, you don't have, it's grayed out. That means now you have to now fill in these values. You need to now fill in these values. Okay. Now the question is how to fill these values. Okay. Now, if you double click on this column 1, okay. In these sides, 36 you have to put. All of you are on this page. Okay, you're done with that 36 resizing. In fact, you can do it later also. That's not a problem. there's no hard and fast rule that it has to be initial. Okay. Now here, this column 1, we will just change it to grade as per the problem. It is because they are talking about average grade. So we'll use this variable grade, variable name as grade. Okay. So grade it is grade, and you press enter so that your name of the variable as well as how you want it to be called. Because it's following some convention of SPSS, like there is a variable name and label, right? So this is like label and this is name. Okay. So this is grade. Now, what type of variable it is? Is it a quantitative variable? It is a quantitative, marks, right? 83.96 average. So it's a scale. Now, you see there are 3 scales being put up here. It understands that scale is something which is purely quantitative, for which mean is meaningful. Then the ordinal scale means if at all you have something like ranking, which can even take categorical values or like textual values, or it could be numerical values also. But you are saying that it is only measuring order, so ordinal scale. Otherwise, it is nominal if you have a purely categorical variable without any order. So we'll choose this scale. Okay. The next thing what we need to do is computing part. Now, here I also want to tell you that JASP is written in R. So it supports now R is a statistical programming language. Okay. Now in statistical programming language, it is very much friendly to statisticians. So it doesn't get into that hardcore. Like I'm also a computer engineer, so I know what are the difficulties in a hardcore programming stance. Okay, so fortunately, our programming was not built by the so-called programmers. So it was built by a statistician, so or a group of statisticians. So they kept the life easy out of how to understand statistics. So in JASP, they do provide, in this not computed, you can pick up, there's something called as computed with R code. Now don't get stressed out, saying, oh, no, we have to learn R. No, I'm not talking about it. It's just going to be an expression, okay? So we are not learning R programming. Definitely not. We'll just have to put up this expression, and I'll give you the idea about what this expression means. So there's nothing taxing on the memory. Okay. Say you can choose this option, computed with R code. Now, if I fill up the right R code here and click on compute, I'll get the data set automatically. Now the question is what to fill in here. For this, now I just want to get this idea about, because this is the only statistic formula I tell people to remember, and which is something which is not difficult at all. Okay. I want you to get the understanding of normalized score. Okay. See, you might have heard about this called normalization of the score, or Z score, Z score, right? So now the idea of a Z score is to make comparisons easy. That means the score what you get, the Z score, is basically a unitless quantity. Okay. and that Z actually means the number of standard deviations a individual variable is away from the mean. That means if you have X as your variable, then the individual variable, say X1 or X2, X3, in general Xi, how it is away from the mean. Let's say you say Xi minus your mean, say X bar. X bar is your mean, suppose, in sample. So Xi minus X bar is the difference between the individual value of the data set and the mean divided by standard deviation. So then you get number of standard deviations and individual values away from the mean. So in general, if I have to write figures, and this is the only formula I'm expecting anybody to remember, is Z is equal to Xi minus X bar. That is the difference between the individual value in the X variable, okay, divided by. So if I actually understand like this, ZS means the Z times the standard deviation is Xi minus X bar. Z times standard deviation, okay, this is here. So Z is equal to Xi minus X bar. How much distance the individual value has from the mean value, okay, but I am measuring in terms of number of standard deviations. See, it is something like, if I have to give an analogy, if there is a 5 kg weight, I am saying that I am measuring 5 kg by taking standardized weights of 1 kg 5 times. Okay, so ZS also means that way. So ZS basically means the number of standard deviations a individual value is away from the mean. Okay. Now, what is the intention here? The intention is that if I know X bar, which is known to us here, if I know standard deviation, okay, then I can compute Xi. That means if I write Xi, it would be, if I just take this X bar away, so X bar plus Z into S. Make sense? Does it make sense? So Xi is something what I am going to compute. It has to be X bar plus Z into S. Now, this is the expression I'm going to write here. Like, not exactly that. Okay. Clear? So what is my X bar? So you can type 83.96, 83.96, okay, plus, okay, I'll hold on that Z part. S I know, right? What is my S? 12. Okay. Correct?
Space.
Huh?
83.96 space plus 1.
Huh. Okay. Well, just like how you write expression on paper, you write 83.96, give space plus give space. Okay. So 12. But now I need to know what is this Z there. So you have heard about normal distribution, bell-shaped curve. It's also called as Z distribution. Okay. Now in Excel, there is a function called RAND. It will just randomly generate value, but then if you want it to generate a normally distributed value, also you can do that. Or for that matter, there is something called as data analysis toolpath. Right? So in data analysis toolpath, you have random number generation there. There you can even fill up the normal distribution and do it. Now it's a little tedious task in doing in Excel the same way. Okay, because Excel every time you have to keep extending the things and so on. Whereas here it is easy. So basically what we are trying to do is this Z is basically a normally distributed variable. That means Z is something which follows normal distribution. Okay. In R, the way you can create this normally distributed variable is the function is called as R norm. Okay, R norm. Norm means normally distributed, and R means you actually regenerate the normally distributed variable. So that is the way it is. Okay, of course, I can get into detail, but I don't want you to get off track with this or get too much overwhelmed with the understanding of this. So it's R norm, and inside that you write the sample size. So it would give a standard normally distributed variable, that is a variable whose mean is 0 and standard deviation is 1. Okay. So, but then it's a fact that when you use such type of function in either in Excel or in R anywhere, it doesn't give you a perfect variable. A perfect variable in sense it will give you the variable, but there would be approximation in terms of your x bar and mean. Okay. So now I want it is like this. Suppose you say that I'm drawing a dog's tail. The dog's tail, can it be straightened? Okay. Okay. So then I used a philosophy that just like how the girls straighten their hair, how they straighten their hair. Huh? Straightener. Your own say. So it becomes straightened out, right? That exactly I'm following here in the statistics also. So what I'm going to do is, I understood that the randomly generated, this was my experiment earlier. Now it has clicked that I'm sharing it with you. Okay. Like I was in the process of scheduling the dog's tail. Right? I was like figuring out what can I do, because I'm generating a variable with mean 0 and standard deviation 1, but that mean is not exactly 0. I want exactly 0. How do you do that? How do I do that? So then I use another straightener for that. Okay. So Z into, so that is, sorry, S into Z, no? So 12 into 12 multiplied by, what is that straightener I used? That means I was able to straighten the dog tail. Okay, what did I use? I used a function here called scale. Okay, in Excel it is called standardize. So I standardize the standardized variable. Sometimes what happens? No, you put suppose there is a dog's tail here. Okay, I want to straighten it. I use the hammer tap. सीधा खड़ा है. Like some sports master, they do, no? They say, if I'm standing like this, I'm kind of straight, but little bent. What will the sportsmaster do? Straighten. So that's exactly I'm doing. So I do this scale. This is the function to straighten the dog's tail. Scale and then do what? Of course, I'm generating the variable. So I put R norm. That means it's a normally distributed variable which I'm generating. And what is my sample size? So please check that the scale is having brackets. R norm also is having brackets. But now this becomes only xi, right? Only one. So I want to create the series of values. So what should I do? I need to have a array or the list. So for that, at the starting, you can just put C. But this is basically to create a array. That means you create a table of values. I'm not happy with only one value out of 36, right? I need to have all the 36 values. It's like making a autofill from Excel. Like you generated one value, but now I want to produce the same formula down. So this C has to be used. C is basically to create a array, and that also you have a closure for the complete thing. Just have a look. So what I've done is I created a array wherein using the mean, okay, using the mean 83.96 as the starting point, then I use the standard deviation 12, and then actually inside R norm 36, I generated 36 normally distributed values. Okay, but that normally distributed values used to have, we approximately get mean of 0 and standard deviation 1, but I'm not happy with that approximation, so I had to straighten that by using the scale function. That's it. We're sorted. So all that now we have to do is click on this compute column. Now, it might be possible that you might get a different sample, I might get a different sample. Okay, you will get a different sample because it is a randomly generated value. But the beauty is, what is the beauty? Okay, we'll see that. You will get a different value. You might have got a different sample. I would have got a different sample. Okay. Now you will see the magic. Go to the analysis. Click on this analysis. Click on the analysis. Just look at the descriptives. You can click on descriptives and say descriptive statistics. Take the grade to variables. So I was able to straighten the dog's tail.
Minimum and maximum you value.
That I'm not bothered. So I'm following the problem with the characteristics of the sample. Have I got the characteristic of sample right? Sample size was 36, mean is 83.96, standard deviation is 12. What sample? Now I can solve the problem easily I want, right? I got the data with exactly the same specifications. So now what do I need to do extra? Apply the test. Okay, that's it. I should know what test to apply. Okay. So we were able to successfully generate the sample. You see, generate the sample. See, you can, okay, there is an option of switching, okay? You have this, there is a drop down from here, right? This arrow punching out. Otherwise also you can click on analyze it. So you can always toggle. See here, this is an arrow. Switch here, comes to data. Switch here, comes to analysis. Okay. Yes. Just take the basis equals. Okay. All right. So I got a sample. Perfectly fine. So now what I need to do, just do the test. Okay. So what is the test? Here I'm doing a t-test. So one sample t-test. So I need to go to t-test. Just select the t-test. Okay. What is the test I should do? Because there's only one single sample. So one sample t-test. I use the classical approach. You can see that there is a Bayesian thing which I told you earlier, but we are not using that. We are going to classical approach of one sample t-test. So you can see that the grade variable has come. All that you need to do is pick up that and choose it here. Okay. Hold on. It's not done. I've picked up this. But what is my hypothesis? U is 87. So you need to say the test value, it has to be 87. So just change it to 87. The test value, you see the test value is there, right? So test value, it should be 87. And accordingly, your t statistic is calculated minus 1.52, your degrees of freedom, everything has come along with your p value. Okay. You can even have some of the, now some additional statistics are also provided here. Like you can check the effect size. I'll tell you what is this effect size. And descriptives. You can have the same descriptives what you got on the descriptive set, but here also you can get it additionally as part of your one sample test. Okay. Now, is my job over? No. So I got the results fine, but now I have to interpret these results. Now, if you look at my hypothesis, it is mu equal to 87 and mu not equal to 87. So have I chosen the alternate hypothesis correctly? Yeah, because your alternate hypothesis, again, those who have still a confusion about alternate and this, even without knowing also you can solve the problem correctly. Right? Because they are clarified here that your alternate hypothesis your alternate hypothesis is not equal to test value. So not equal to test value. So so what is the crux of the story is that you need to have your hypothesis right. If you write the hypothesis correctly, then it's a cakewalk. No, there's nothing much to do. So you have this hypothesis set up correctly. 87, test is fine. Then these are some of the things which you can have it. I'll tell you what is the use. Okay. Now, so all of you have done this. Sorted, no? You have got the same result. This is the same for everyone. Okay. Irrespective of your sample. Is clear? Now, let's understand this statement. What are we trying to prove? This is, say we are not using critical value approach. It was meant for those who want to use the table. So we are not using that approach. We are using the p-value approach. Okay. Test the hypothesis at 5% level of significance. Okay. Now we are using this p-value approach. So here we have this something called as p-value. Okay. Again, there is a story behind p-value. Anybody has a coin? I don't have. Anybody has a coin? I already told some of my doctor students about this. Okay. So those who have already seen this, please don't interrupt. Okay. Right. So now actually I didn't see whether I assume that he is a nice guy and he'll give me a fair coin. Okay. He'll give me a fair coin. So what is my hypothesis here? What is my null hypothesis? As far as the status quo is concerned, that this coin is fair. Okay, so alternate hypothesis will be the coin is unfair. Okay. Now I'm going to do a sample trial. Okay, considering that this is a fair coin. Okay, I toss the coin. I get a tail. Do you believe that I get a tail? Don't say that my tail is coming. Okay. Right? So what is the probability of getting a tail from a fair coin? 50%. 50%. I get a tail again. Do you still believe that I'm telling the truth or it is a fair coin? So what is the probability of getting two tails twice? 25%. 25%. Yeah. I get a tail again. Do you still believe that it is a fair coin? Huh? What is the probability of getting three tails? 12.75. 12.5%. Let me try once more. What a lucky day for me. I get a tail again. Okay. 6.25%. 6.25%. But do you believe still? Yes. That it's a fair coin? Just one more. I get a tail again. Do you still believe that it is a fair coin? What is the probability of getting 5 consecutive tails? 3.125. 3.125. Okay. 0.03. 3.125. But for probability, so percentage of the 3.125 percentage. Also 0.03. Okay. That's to cut the long story short, I could have still gone and kept on telling you that I got A's, even without C. Okay. That means, see, if I continuously getting what I say, the tail, naturally the probability of getting such tail will become very improbable. Getting it down. Yeah. That means whatever the probability you get here, that is actually the p-value. The p-value which you see, it's actually the p-value. That means if the p-value is 0, what it basically means is the null hypothesis can be rejected, because it's very unlikely that I get, say, suppose I get 10 tails, considering that it's a fair point. The only possible thing is that it's not a fair point. Then only there is so that means it's a magic coin. Okay, that means it is shying away from the null hypothesis that it's a fair point. So as the p-value approaches 0, it means that your evidence against the null hypothesis becomes more stronger. Okay, so the p-value in this case seems to be 0.137. Now, how do we treat this thing? So in general case, when we are talking about p-value, we generally say that anything if it is approaching 0, that means you are 100% sure that null hypothesis is going to be rejected. If it is 0 means, but then we have some problems there. Okay. Like here, there is another thing which I generally used to tell my students is, okay, like in a typical, like at least in old movie, I've seen such type of things. In typical Hindi movie, like there would be some smugglers, taking their truck. Okay, and they see there is a barricade or police barricade. Most of the time, they'll bash that barricade and go to reach their destination. Okay, imagine that type of a scene. Okay, yeah. Say there the destination of those smugglers is the p-value. Okay, that means they want to reach somewhere, taking some gold smuggling or okay, and then they have to surpass the barricade. So one such truck is moving, and those thieves realize petrol खत्म हो गया, तो barricade तक पहुंचा भी नहीं. That means it has not even reached the barricade. It could not surpass that barricade. Now that barricade is something which we said as a researcher. That means there is something to compare p-value with. Okay. So the p-value comparison, we compare it using what we call as alpha. That is the one where we assume that if the alpha is not reached, so p-value is not reached to that destination. So it's something like this. Let me graphically draw this. There is okay, imagine that is a smuggling truck. Okay, there is a police barricade here. Okay, and that this is destination 0. Okay, that is your p-value. Okay, now this is approaching, fast approaching here, and the petrol gets over. So that means it didn't even touch the barricade. Okay, so it's far from zero. Right? Actually, if it surpassed that, then it will become lesser than this value. It is in the decreasing size, no? So if the p-value is less than alpha, then it is like closer to zero. That means you can reject the null hypothesis. But if it doesn't even surpass that, that means it is still greater than the alpha value which we have set up. That means there's still not good evidence to reject the null hypothesis. So in this case, what happened? Your p-value is 0.137. Okay, that means it is like assuming null hypothesis is true. Like if you recall the experiment, okay, the probability of getting that event is 13.7%, pretty large. And I was thinking that improbable situation, when it will happen, when it is less than 5%. So typically we say alpha as 5%. This is what we said. So alpha can be 5%, or it could be 10%, or it could be 1%. Most often, for more rigorous, you may go with 1%. Very less rigorous, 10%. Optimum one, 5%. So 1%, 5%, and 10%. Right? So your p-value, if it's less than alpha, then you say that there is enough evidence to reject the null hypothesis. But in this case, we see that there is not enough evidence to reject null hypothesis. And that's why we can still go with the students' belief that the average grade is 87. Okay. Now, this is also complemented, okay, not necessarily every time. It's also complemented with what we see here as the effect size. So if you see this, there is an effect size been given called Cohen's d. Okay, I think the Cohen's d value is talking about the practical significance. Right? So there might be some result which might be statistically significant, but may not be practically significant. Or other way around also it's possible that statistically it might be insignificant, but practically it might be significant. So Cohen's d is such matrix which wherever, suppose that in any of your research work, if you find that when you're doing a test, generally they also tell you to report the effect size. So effect size basically talks about practical significance of your result. Now in this case, the Cohen's d value is very small. Okay, I think there is a limit to this. You can clearly see that the Cohen's d nodes are okay. So small means 0.2.
Yes, sir.
In the note, academic note of t-test, no? In the typical result of t-test and the interpretation, right? So in the academic note, the Cohen's d value, if it is like irrespective of the direction, I'm saying, the absolute value of that, if it is closer to 0.2, it is small. Right? You could see general notes on t-test in JASP before the problem set came. Okay. Yeah. So that means here it is also practically insignificant because it is small effect size. So small effect size. So even if you do not consider statistical evidence to the core of this thing, still your effect size is very small. So even with this, on these grounds also, your null hypothesis cannot be rejected. Clear on this? And please always note that again, this is something one blunder people do while reporting in the research is they only think that p-value reporting is enough. You also have to report your descriptive statistics because the story comes from that. Once your statistical result is significant, then you can bank on your descriptive statistics to tell the story, right? So you need to tell, of course, here it is insignificant, so this may not be that immaterial, but then you need to give the descriptives also saying that, okay, 83.96 and 87 might be very close to each other. Apparently, it is very close to each other, right? That's why the null hypothesis was not rejected. So you can add that story that, see, of course, we did this test of being very robust. Okay, but then could see that 83.96 is how much? 84, 84, 87. Not that big a difference. So that we can support that way. So descriptive statistics is equally important. Right? Hope you got the idea. Okay. So this is about one. So this took some time because this is a starting point, right? Now we can gather up quickly. Yeah. Okay. Now let's move to the different problem in t-test. Okay. One good thing is that when you're doing in JASP, there's a lot of editing features also which are available here. One is that, let's say you wanted to organize your tests in particular sequence, you can always do that. Let's say I didn't want descriptive statistics, which we computed earlier. I can remove that immediately by putting a cross. Okay, like for instance, this one I don't want. Then I can just put the cross. Good. I can even toggle. Okay, for instance, if I want, okay, this has to come next, so you can pull over this. So your results also will be shifted there. The advantage of this is that when you want to copy the output and paste it in Word document, you can organize it here itself and then copy and paste it at a stretch. Okay. Like for instance, I want to go to the print the results, right? So you can just copy from here, the results section itself, you copy this and say open the Word document. Okay. And then you paste it over here. It comes out neatly in the same order, without any hassles. Not only that, okay, I did this, but however, if you want to make it more contextual in sense, let's say I want to know what is this one sample t-test about. You want it to be understood by you or by your colleague with whom you are sharing your work. So what can be done? You click on this, you can see there is an edit option. Once you click on this, there's edit option here, pencil. So this, you click on this pencil icon, you can see there is an option of editing that one sample t-test. Or you can write, okay, one sample t-test. You can contextualize this based on your need, and then you can take the printout also. That's also possible. Say one sample t-test about statistics grade. And then after doing all this editing, you can just go and put the results and paste it in the Word doc. So that also is a okay. Yeah. So these are some of the features in general. You can save your file if you want to like, take it in your pen drive. It's okay. So I'm save as. You can save it wherever you want to be. And when you save this file, it will be a JASP file. I'll write it as t-test, one sample. Right, so it will be saved. Right. Okay. Now what you can do is just close this file. You can just close, only close, not exit. Close this. Okay. Then you come back to your original page. I think we can take a break now. It's 3 minutes. That instead of starting anything in hurry. Okay. We'll take a break and we can gear up now. Because now that we have got the basic introduction, you know it should be okay to fasten this speed. Right.
So, the snacks are here. So.
See? It's like what is where did you
Shall we get started?
Yes.
Okay, please tell it down.
Has been sent to me. I think somebody will consider that we don't know whether it's and that really waste whether he's seeing it and look at that.
Okay, welcome back. So in the problem sheet, of course, we have little bit going to fill over, but it's okay. We overall we will be adjusting the timing. So in the problem, the same problem set, you can consider looking at question number 9. Question number 9. I wanted to take something from the HR perspective. A recent Time magazine reported the following information about a sample of workers in Germany and United States. Okay. So they are provided the average length of work week in hours, then of course the sample standard deviation and the respective sample sizes. Okay. So United States and Germany. United States, there was a collection of some 600 samples, like where they actually asked what is the work week in hours to the 600 individuals in United States and 700 individuals in Germany. Again, they asked the same work week. Okay, so work week hours. Like here, maybe one question might have been posed that how many hours you work in a week, and they just gave this option. Right. Now, of course, in India we have now 70 hours work week. 70 hours. The other person was saying 90 hours. Okay. Right. So now here again, I'm just passing this data. So here we are saying 42 hours work week in US. Luxury. Or they are talking about professors' levels. 42 hours, possibly because if we are considering our case also, it will be around roughly 8 hours, 9 to 5. 48 hours, 6 days. 6 days. So they are here they are saying 42 hours. Consider maybe 5 days, something like that on an average. Right. So 42. So now what are we planning to do here? We are just checking whether there is a significant difference between the average work week of the United States and average work week in Germany. Okay. Now clearly there are two different samples from which the data has been taken up, and we are trying to compare the two different populations, one from Germany, one from US, in terms of the work week hours characteristic. Okay, so that is the idea. So in general, I would like to ask a question to you that how many variables you would think there would be? There will be two variables, one indicating what? One indicating the country to which that data belongs to, and the other indicating the work week hours. That means you have one quantitative variable and one qualitative variable as part of the data set. What do you think is the sample size of the data set overall? 600 plus 700, so 1300. That means we should have a data set with us of 1300 observations with two variables, one having work week hours and the other indicating the origin from where that information was collected. Okay, here. So two variables, one quantitative, one qualitative. Okay, of course, qualitative is a categorical variable completely, which has okay Germany and USA as the indicator. Now you need to do the comparison of the average means across these. Okay. Now, how do we go about this? Is see, we have to just get an extension from what we did in the previous problem. Okay. That means you need to have two different calculations and club together. That means for each sample, we need to use this sample standard deviation and sample mean and then club them together. Okay, especially when you are taking work week hours. The other new part which you might be learning now is how to create a categorical variable. Okay, so that is the new addition in this segment. Okay. So you can again press new data. Let's start with column 1. Now column 1, okay. Column 1, what are we doing? The whole sample size is 1000. Let's close this. Close. Same one. Okay. So column 1 has to be resized to 1300. So resize data and 1300 you can write. And how many columns we have? Two. So we can do that as well. So 1300 and this is 2. Okay, I think there's something wrong. So if it's not happening, don't worry. Let's press OK. Let it be 1. We can add it later. I thought it should have done. Huh? It's happening? Yes. If it's happening, it's fine. Otherwise, there is another plus you can do and then create another way. See, there is another plus, right? So in my case, it didn't happen for some reason. You can click on plus, it will create another variable.
Should I do resize?
Yes.
Yeah, resize, yes. So in resize, once you do is enough. So this, I think it's not resized mine. That's the reason so I should have 1300 is your rows. And
That is not good. So I will use caps, sir. Otherwise, it is not moving somewhere.
tab.
That's it.
No, I just couldn't change that at all.
It's not working. 1 minute.
Resize, sir.
Reset. Okay, let me just do it. No problem. We can do it once it's okay. Once and then I'll click on resize. Yeah, let it come. Okay. No problem. So why the break head for that? Right? Okay. So we got for first column, resize it to 1300. Okay. Huh? Two columns also good, well and good. So what you can do is just go to this column 1. You can click on this. This column 1, we want to give the work hours. Right? So work hours, something which is known to you how to do it. So what we'll do, just make it what work week hours. You can label this as work week hours and enter. So work week hours, you click on enter, then your long name also comes up. Then it is a scale variable because it's quantitative.
There can't be any gap between the words, huh?
So you can create. Yeah, it will take it. So this is my convention. I generally put a thing which seems to be, then I make a capital work week hours. Otherwise, also you give space, also no problem. It will take care of it. Right. And then here again you do using R code. Same idea, but now you have to do what? 2 times. And separate it by comma. That's it. So we will have to do it slowly. 1 minute. So what we'll do is just put C. Okay. C is the starting point to make it an array. Last time I showed it in the lab because I wanted to understand the concept. Okay. Now what we have to do? Let's start with. Okay. Let's start with United States. So United States we are starting with. In the United States information, what is given?
Mean is given 42.
Mean is
42.
so that is X bar 1. Okay, let me give you the information over here to understand this. Your X bar 1, that is X bar US. X bar US is 42 and sample standard deviation of US is 5 and N small US is 600. Okay. So now what will we do? We will write 42. Now, because we are having 2 sets, please start with a bracket so that the confusion doesn't arise. Like now, first we'll finish with the US. So 42 plus 5 multiplied by scale R norm bracket 600. Now ensure that apart from the C bracket, all the other things are closed. So 1, 2, 3. So 1, 2, 3. That means we finished with the first part of that unit part. So you started with C, you opened that, then just to ensure that you are having this set. So 42 plus 5 into scale R norm 600. And then apart from the C bracket, all the other things have to be closed equally. Right? Then put a comma then put a comma because now you have to do it for Germany. So for Germany, you have information as your X bar Germany. X bar Germany is 38. S Germany is 6. And N Germany is 700. X bar Germany is 38, S Germany is 6, and so now repeat the same idea with these different values.
At the end, there will be four now. Four.
Now in the end it will be 4 because you have to even complete the C. So you open this, then write 38 plus 6 into scale R norm 700. Okay, 1, 2, 3, 4. Compute column. Click on compute column and you got this, right?
India express. I think India extract. This one starting with this. Yeah. That's the bracket. Set your brackets. Set your brackets clearly. Opening and closing brackets, just match it properly. What is extra brackets? That is reason you just be systematic here. Okay, got it? Now we have to create a categorical variable. Some of you have already got the other this. No problem. You can now just otherwise also if you want to create another variable, you can click on plus. Okay. And here you can name it as country. You can just name it as country. So which should I go now?
The plus. So you can put it as country. Country. And then enter. No, is it okay? Country, let's change it. Okay. Is it a categorical variable? Is it a categorical variable, right?
Yes, sir.
So make it a categorical variable by nominal. Country is a nominal scale variable. Okay. Now here you say compute with R code. Now how do we get? Now what is the idea now? For the first 600 records, it was for
US. US.
US. Okay. No, you don't have to. One also you can put, but let's keep it original idea. SPSS will follow the current. Okay. Now
Here what we need to do is, that is the first 600 records, the US has to repeat. US, 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 US. Okay. Then followed by
Germany.
Germany, 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 Germany. So 600 plus 700, 600 times US should repeat, 700 times Germany should repeat. So we follow this. Of course, we have to start with C. Okay. C in opening. Here it is, thankfully in R, they understand the plight of people. So there's a simple function they have kept. Okay, called rep. Repeat means rep. So REP, rep. Okay, rep. Then what you have to rep? First is
US.
US. So you can open the bracket, rep, and in quotes, वो चलता है, SPSS नहीं है. I keep on pointing that out, make that. So you can put US and then put, if you want, you can write United States also, no problem. Okay, with space, everything. We'll still take it. Okay, US, then comma, how many times?
600.
So write 600 times. Then close this,
Comma.
then put a comma. Then rep. Again, you want write Germany, you can write Germany. I'll write Germany completely. $700 times. Close this rep, and you have to close the C also. You put comma and wrong, see, 50 brackets and saying, you know that. Okay, brackets. Brackets, 50 brackets. You are not putting bracket here. See, I said the whole set has to put a bracket here. After, that should be two brackets. See, it should be one set. Huh? So,
Red mark.
red mark क्यों आएगा? So it came to me. Which got it? Huh? नीचे है ना? Okay. Complete problem. So bracket can put. Oh, where's this one? Right. Even if you put bracket, you have to close it. Okay. So you have this work week hours, and all of you got it?
Sir,
Hmm?
the country code. Country code, can you just show it?
All of you got it? Any issues? See, even if you are getting an error, it is nothing wrong in the code. It is only brackets thing which, if you have not have equal number of opening and closing brackets at the right space, then only you get that problem. Otherwise, there is no problem. Okay. Brackets check करो भाई.
No, it's exactly, it's like a surprise part. This is the first question, but now we are dealing with the dialogue one. This is the, this is that, I take like, this is it. Now we have to like.
Comma. 600. Close. Comma. Yeah. Close. कुछ करेक्ट हुआ है देखिए. Okay, are you done with this, right? Now, so we are done with the data creation. Okay, so we have this already got the data. Now it's question of what is the question? The question is we want to determine whether or not there is a significant difference between the average work week hours of United States and average work week in Germany. So is there a significant difference? So what is this? Is it a null hypothesis or alternate hypothesis? Huh? It is an alternate hypothesis. So basically you are checking for, what is the hypothesis here? That mu of US is equal to Germany, or mu of US not equal to mu of Germany. Different means not equal to, right? So that becomes your researcher's hypothesis or alternate hypothesis. Whereas the null hypothesis, as I stated, that it should always have a limiting value equal to sign. Now the other way, this is where I'll bring the third perspective of null hypothesis. The third perspective of null hypothesis is that null hypothesis, as the name says, null, it means that there is no relationship between the entities into consideration. Like here, what are the two entities? One is the country, another is the
Working hours.
work hours. Now, if there is not a significant difference between the two countries, that means the work hour does not depend on the country. Correct? That means if I say that if these two are equal, what does it mean? It means that the average work hour does not depend on the country. So that is another way of expressing your hypothesis. So we do not assume any bias in null hypothesis. Bias means that there is a relationship, right? When we say there is no bias, okay, that is the no bias perspective of null hypothesis, wherein we say that there is no relationship between the entities concerned. Here, in this case, the entities were work hours and country. So that is the third perspective of null hypothesis. Okay. So whenever you say that there is a relationship, that means it is the researcher's hypothesis. That means you are defining the null hypothesis. Okay, you say no, there is a relationship. Okay. Okay. Now that you have the data set with you, what next? Again, this part can be different for different people. Of course, this is same because but here we are normal distribution sample you have created. This has become different. But when you go to analysis, now this is a test where we can carry out independent sample t-test. So you can go to t-test and carry the classical independent sample t-test. Okay. You can take the work week hours in the dependent variable and country as the grouping variable.
It is mentioned as split also, grouping variables.
Grouping variable is a splitting the sample. Grouping variable is actually a splitting the sample into two groups. Right? No? And you see there is alternate hypothesis, which one you are choosing. So here we are choosing the first one, right? So based on that one, you can get this. Okay, now one important point. See, most of the time, especially when it comes to comparing from two different populations, okay, your independent sample t-test, there are different types of statistics involved. This is where for students also it becomes complicated. Right? For instance, one thing which often comes into picture when you are comparing two or more populations is the assumption check of homogeneity of variance within the group. Okay. Like in this case, how do I know that there is a homogeneity of variance within the group? Okay. As well as, see, not only within the group, even across the group. For instance, in one section, my marks of the student, average marks of the student is 60. On the other side, we have say 70. Okay, now apparently it looks like the other section has done well. But you can still contest that saying that, okay, average has come 70, not because of everyone doing well, but because one fellow got 100, whereas everyone here got 60. That's why they got 60. So that means there is a variance inflation in the second category, thereby it is unfair to compare them. There might be one topper who has got 100, and that's why he pulled it up, the average performance to 70. Whereas here everyone was consistently getting 60. So you see that could be a violation of variance. So that is the assumption check which you need to do. Now, luckily, see by default, generally in the independent sample t-test in JASP, they take the student t-test. Now, student t-test statistic is assuming that the homogeneity of variance is maintained. Okay. But strictly speaking, you need to check that. Now, what happened here is when you are got the result, it is telling you that this Brown-Forsyth test is significant, suggesting a violation of equal variance assumption. That means student t-test is not appropriate here. The student t-test is not appropriate here because there is a violation of. So take care of this. That's what it is indicating to you. Okay. So there are other t-tests also. That is another t-test called as Welch t-test. Now Welch t-test is used when you do not assume equal variance across the group. So equal variance across the group, right? So student t-test assumes equal variance across the group, whereas Welch t-test does not assume equal variance. So just to be on safer side, you can even check the Welch t-test. Now you see it has that has got cleared up because you have even taken care of that, right? In fact, now here student t-test is not applicable because it was violation. You can uncheck that. Unnecessary confusion should not be there. You can uncheck and only keep the Welch t-test. Okay. Now, why did we go for Welch t-test? Because there is a violation. So you can even check that. See, there is an option of checking. There is an option called equality of variances assumption check. In fact, there are so many assumptions you should ideally check. We sometimes get because we are in pursuit of publishing paper, no? So we don't want to check all these assumptions. Okay, if they point out, if the reviewers point out or the editor points out, or you have to do this assumption check, then we do it. Otherwise, for us, the publishing paper is important, no? So that's why. So that's why we do not check these assumptions, right? So, but ideally speaking, you should do that. So you should go for equality of variance check, and thereby you can see that it has violated here. That means the p-value is significant here. It means that your test of equality of variances failed. Your null hypothesis was variance of first group, US group, is equal to the variance of the second group, which is not true because of the significant result. And that's why this has got violated, which it gave you a warning signal when you use to the student t-test. Okay. So this you can actually, strictly speaking, you should check this. Okay, not blindly put up the test. You also need to check whether that assumption holds good based on which the test has been formed. For which one? With Welch t-test also, your null hypothesis is rejected. That means even after unequal variances were assumed, not assumed, was proven by the assumption check. You have used the Welch tree test, and Welch tree test is giving you this result. Okay, that means we did a safety check. After that also, my null hypothesis is getting rejected. That means we are by far means saying that the null hypothesis is rejected. Most often we resort to a shortcut. This is a who cares? Nobody was sees that now every time theory building in research we keep saying. So who cares for the results? So, but especially this should be checked. Okay, otherwise there could be some reviewers like me who will nitpick this with this that thing. Pick. So I'll definitely pick people if somebody doesn't put a assumption check. Okay. Yeah. So group 1 not equal to group 2. I'm using Welch because it's violation of equality of assumption. That's what I mean. Otherwise, you can use student. Okay. See, again, even in assumption check, it is actually essential that you should also check for normality. Okay. Now here I'm not doing normality because we have created the data set using normal distribution. So if you check normality, it will be it.
Result suggest a deviation from the.
But it is not significant, no? It is normal because we generated from normal distribution. So definitely this will be p-value will be very high. So normality assumption is okay. Both are same. Levin's test or Brown force set both give the same thing. Right? It is like taking cosine and tolu. Both do the same effect. Yeah. Any doubt? Yeah. Yes. If normality assumption is violated, there is another test called Mann-Whitney U test. Now, Mann-Whitney U test does not it doesn't take account of normality assumption. It is a what is a non-normal test.
Non-parametric.
Non-parametric or non-normal also you can say because it doesn't assume that it is a normality distribution should be assumed.
Is there only we can check normality through Shapiro-Wilk or some other? Like, can we check it to the skewness of kurtosis also? Because primary data most of the time is very difficult to have normal data.
Don't check. If they ask for it, then it will go for some explanation. Then that's the most of the time what happens is that if the suppose it is violated, right? And now data bigger here. Then you identify some papers where they say
Even if it is unidimensional normality is achieved, multidimensional normality is never achieved, sir. Very rare.
there are all practical difficulties while collecting the realistic data, right? So realistic data you will not have that, but then you can either carry out a different test. Like here you have a solution that if the normality is not achieved, then you can go for that Mann-Whitney test. So there is always a solution for different types of data. So if it is a non-normal data, go for Mann-Whitney test. If it's a normal data, but if it is non-equal variances, then Welch. If it is equal variances, then student.
But both of them for normal data.
Normal. Okay. You can even go with, as I said, the other thing is about effect size. So you can check the effect size. Now, effect size also gives you a good indicator saying that it is 0.724. That means it's more than 0.5, right? We saw that in our notes. So in the 0.5 and above, 0.5 to 0.8. So it is closer to 0.8. So there is a large effect. That means practically also this is a significant difference. Practically also it is a significant difference. This point, okay. Now, what else? Oh, no, you have this negative sign. What does this indicate? Negative sign. This is where, again, in some research papers, I see that if you don't go beyond inferential statistics, you don't have any story to tell. So, the story here is you need to put the descriptives in support with this. So, what happens when you put descriptives? You get the real story behind this. In the descriptive, what happened? Of course, now here we know it that US has significantly more work hours compared to Germany. That means working in US is more stressful than working in Germany. Right? Then your story comes. Okay. What makes Germany people work less? Is that they have really taken some initiatives to ensure that there is not much of stress on people? So that's where the story of your research begins. Okay. Or is it that in US the policy is treat humans like machines? Like you can have some strong statements based on this evidence. Okay, it's like when you want to kill people, you want license. Kind of. Okay. Like somebody kills a person, he says, "Yeah, I have gun license, so it's okay if I kill." No, of course, it's not okay. But then the person is not feeling guilty about it. They're saying, "No, I have license. That's why I killed." So the problem is that once you have, my idea was not to go to that extreme. I'm just trying to say is that if you have statistical evidence and you have a story to tell, empathetically, you can punch on that by the descriptors. So now I have this, I have practical significance, I have statistical significance. Okay, this has empowered me to tell the story that Germany's work life is better than US. Okay, it's way better than. So then you explore that. So then you unfold the story. Okay, what really happens in? You might have a qualitative study support that.
Wednesday also shows minus. What does it mean?
It means we have compared group 1 with group 2. Now group 1 here we have considered US. 1 minute. Work. Yes. Okay. Sorry. No. Sorry. No. Here. Sorry. If you see, that's the reason descriptive is important. When it did the group descriptive, what did it say? The first group, what it's showing? Germany. That means Germany has been taken as group 1. Germany has been taken as group 1. And US has been taken as group 2. So when you are taking the difference, so this group 1 not equal to group 2, basically you would turn out to be group 1 minus group 2 not equal to 0. right? And that's the reason it became negative. Because your x1 bar, that is x bar, here x1 bar is not US, it is Germany. So 38 minus 42, that's why it became negative. Is clear? So, again, that again holds my point clear that you should always supplement your inferential statistics with descriptive statistics. Okay. Otherwise, as sir asked, this question would be there even in the minds like, okay, what does this minus mean? The minus actually has to do with, because the group one was Germany, as from the software you can clearly indicate, see that the group one it has considered as Germany and group two it has considered as US. Now these type of teething issues would be there. That's the reason in the traditional softwares like SPSS, they tell to put one as one, group one as you, like they want it like a dummy variable. Okay, for same reason.
So for the same reason, points D is also coming minus.
Yes. Okay. Yeah. Right. Okay. Yes, you can. What you will do is, while labeling, you do that way.
Here, sir, when we were leveling, we mentioned US first, Germany next.
See, it takes,
Randomly.
no, not randomly, it takes an alphabetical order. Yeah, but then you can put 1 and 0.
US is America.
There are various ways you can code it to make, either you just make it like group 1 itself, you write. Group 1, group 2. Then instead of US, you write group 1, group 2. Then yeah, you have to tell which is country 1, country 2.
Is alphabetic. It can be alphabetic.
Yeah.
I change it to American.
Yeah, or you can write 1 and 2 also. Nobody will see here when you are using in this country, you can change this. Instead of US, you can put 1, and instead of Germany, you can put 2. That's all. In the quotes itself, you can put 1 and 2. So you can code it that way also. Okay. Yeah. So you can.
My table for the independent sample t-test is exactly what you are getting. But assumption check, some of the values are different. What can be something?
That could be because of different samples.
Even with complementing in order, it is Germany.
Here, what we did, we put America.
I put America only.
So it's coming from, coming, American, if you put America, it's coming from.
Right. So you can just save your file and we'll proceed to the next set. Save your file and you can close that file. Okay. We'll take up one problem now on the next set. So let's look at, so we had on HR type of question. Let's take a marketing question. Yeah, you can take question number 7. Question number 7. Like mostly like Salesforce management. Question number 7. The following data presents the number of computer units sold per day by a sample of 6 salesperson before and after a bonus plan was implemented. Okay. Now, so there are 6 salespersons, and the salesperson's target was recorded before they introduced a bonus plan, like what they achieved. And after the bonus plan was implemented, the hypothesis is that because of bonus plan, they would have got motivated and would have done better. Right? That is the expectation, right? Bonus plan will motivate people. So it has some HR perspective again, maybe OB perspective, that it might motivate because of incentive. So before and after. So now, if you look at the question, it says at 95% confidence, test to see if the bonus plan was effective. That is, did the bonus plan actually increase sales? Okay. Now here you can take different stances. Okay, up to you. Whether you want to check, as if you want to check after is greater than before or before is greater than after. So that be clear about when you are using the test. Otherwise, you have to just implement this as before and after as it is. That means you just need to record the data as it is. Okay. Now, you can use new data for this as well. You don't have to go to Excel and do this and save it. That option also is there, but you can do it here itself. How much would be the size of the data here? Sample size is 6. So you just need to resize the data. You don't require salesperson. It looks like only serial number. So salesperson is not required. Just keep before and after. Okay. So 2 and 6. So number. So let me go one by one. 6. So 6 rows. I'm resizing it. Okay. Now column 1. So column 1 here basically means before. So let me give context to this before bonus. Before bonus sales. This makes sense. So before bonus sales, okay, enter. It is a scale value, quantitative value, and you can compute with R code. Now here the computing R code is nothing. It is just listing those values what is there. So what you can do? P, just list the values in order before. So C 3, 7, 6, 8, 7, 9, and close it. This is easy, pretty simple, right? And compute the column.
Can we directly enter here also?
Yes.
Huh?
And directly enter here.
You can do directly enter there also.
Then enter there.
I always find this easy.
Yeah.
Or at a time you put, see, why use different methods for different things? The tempo may vary, right? Okay, so this is done. Same way I'll have after bonus sales. Enter computer. So C and then
6, 5, 6,
6, 5, 6, 7, 8, 8. Okay. Compute column. Right. Done. Now, you see, we are talking about the same salesperson. Okay. Same salesperson before and after. So this is where we are not referring to two different samples. We are referring to the same sample and just looking at their performance before and after any intervention. So here the intervention is the bonus plan before and after the intervention. So overall, we are seeing whether if there is any benefit or effectiveness of bonus plan we are ascertaining. So for this type of thing, we make use of a t-test called as paired sample t-test. Okay, so paired sample t-test, you can go to analysis. And we have this t-test with paired sample t-test.
Just because we are looking for the difference.
We are looking for the difference from the same sample. That's why it's called paired sample. It's called paired sample, it's called matched sample, it's also called as dependent sample.
The earlier case it was not from the same sample.
Yeah, they are from two independent samples. Here it is a dependent sample. Same group before after.
Can you say here you are using the status quo perspective? Yes.
No, we are just checking not status quo
In terms of
perspective.
null hypothesis, can we
See,
say that-
no, status quo perspective doesn't suit here. Still, it is equal to perspective, which makes sense. Like, is it, are they better off after bonus plan or they are still the same?
Equal to greater.
So, most often what happens is, here you take a direction, like there's an expectation that with bonus, you want to, you expect an improvement in their sales performance. That is a, like with incentive, you expect a improvement in the sales performance. So what is your alternate hypothesis here?
It is
Alternate hypothesis will never have equal to.
it is
One minute. Okay. Hold on. Okay, even the no bias perspective can hold good. Help. So let me write it in two ways and take whatever you feel is acceptable to you. One is we are talking about H naught, wherein mu before, okay, obviously, okay, see, what is the equal to perspective says?
There's no change. Distance.
So mu before equal to mu after. Don't expect any change. So it goes with the third perspective also. There is no change before and after. Okay. But as a researcher's hypothesis, what is your expectation?
After it has increased.
After has to be increased. So you expect that mu B should be less than mu A. Mu B is less than mu A, or mu A is greater than mu B. I'm writing in this convention because I just wanted to be consistent in the side what I take. Okay. Now, because of this, that it is taking a direction, unlike the previous two questions where it was bidirectional. Here we are taking a direction. That means it is going in this less than sign here. If I keep like this, that means here what is the thing?
B is greater than.
Greater than or equal to. Okay. Like what are we saying is they are going to be opposite. They are your alternate hypothesis and your null hypothesis will be at loggerheads. So whatever you expect in alternate hypothesis as a set direction, please note that alternate hypothesis never have an equal to sign. Only null hypothesis has that license to have equal to sign. Okay. Alternate hypothesis doesn't have that. So you have to take a stance there. Right. Now that you have taken a stance that your mu after should be greater than mu before, then it essentially means that in null hypothesis, you have to take the other way around. Like even after bonus plan, there is no difference. Maybe still your mu B will be sometimes more than. So the intervention has not helped. That's what you are saying. The intervention has not helped at all. Here, makes sense? So this is one way of writing. The other way is like what we are generally comfortable now, write in non-statistical language. So non-statistical what? English. So English, what will write English? Okay. In English, we can simply write that there is no relationship. There is no relationship between. No. There is no relationship between bonus plan and sales performance. Okay. There is no relationship between bonus plan and sales performance. That becomes your H0. But would you report this in your research paper?
No, sir.
No, you should not. Because it is a null hypothesis. You should, because researchers should tell researchers' hypothesis. So researchers should say there is a positive relationship. There is a positive relationship between bonus plan and performance. You have to take this stance. Positive relationship. There is a positive relationship because of this intervention. We got good results. Okay. Yeah. Right. So whichever is comfortable. So typically people take this way out because everyone wants to shy away from the. And I am not seeing people writing like this unless they are from Chinese. No, they always write like this. Chinese authors say they may prefer writing like this. Hypothesis. Indians and most of us, we want to write in English because English, even if there is a mistake, no, nobody cares. No, as long as it is H1, H2, H3, right? Okay. So what do we do? Yeah. Now comes your here. You see, it says variable pairs. Okay. So of course you can take one at a time. Also, it will fill up. See the other thing which will fill up. So before bonus, so what is your measure one here? Before bonus, what is your expectation? The before bonus sales should be less than after bonus. So you should choose that third one. So has it benefited? Huh? No, it has not benefited. You check the effect size. You check the effect size and the descriptives. Effect size is 0. बोनस में कोई दम नहीं है. Now you can have a very strong statement. You can see the average before bonus sales and average after bonus sales. Same. It does not make any difference. Now you can bombard. Now you have got lessons. The incentive does not work in motivating the salespeople. Then you say, okay, salespeople need different type of motivation, and then you can start writing stories. Certainly, bonus is not the one which is giving an incentive. Of course, people might question only 6 people you are asked. So bigger sample size will be better, right? So even effect size is 0. So that's how the story. So the p value anyway is saying you 0.5, 50%. Okay. So that means it is way too high than 0.05. So null hypothesis is not rejected. So there is no use of giving bonus to the salespersons. Okay. They are not improving with that incentive. Yeah. So this is about dependent sample t-test.
Yeah.
It's called dependent sample, paired sample, matched samples.
So here also we are taking student test. Can we go for the other alternative one also?
You have to actually check for normality. Now let's see normality check. We didn't check for normal because we didn't create the data. Normality.
Suggested division for moment.
No, it's not, it is
Still.
it is normal. You could see 0.607 means what? That means the data set is normal distribution. The data set is following normal distribution. Okay, so student t-test can be taken.
It was not there.
If it was not, then you could have taken Wilcoxon sign trend test. That is a non-parametric test, which does not assume normal distribution. Even with that also, suppose you don't assume normal, you can still check it if you want to. There's no harm in checking it. So Wilcoxon also, what does it do? Does Wilcoxon say something different? No. Wilcoxon also is, so it's not telling any different story. Okay. So in any ways, it is understood here that the bonus plan is ineffective. Your conclusion is the bonus plan is ineffective in motivating the salespersons.
Sir, at a more basic understanding level, without getting into this numbers and pairs. What, I mean, as a layman, I can see that before bonus it was 40 overall, after bonus it is 40 overall for 6 people. So can we blindly say that it is?
No, we can't. This is where one of my mentors, research mentors used to say, see, it's not, everyone knows that when there is a banana peel on the floor and you step on it, you will slip. So that is not interesting. Okay, what is interesting is at what angle if you step on the banana peel, you get maximum damage. So the answer to your point is that yes, apparently we are also getting the idea, but we want to satisfy ourselves.
So my question is, suppose and it be the case that in the after sales, let's assume that 5 of them are getting 0 sales. Let's assume hypothetically, one of them is single-handedly getting 40. So which parameter in our table, and it be the case, which parameter in our
Then it would not have been normal distribution. So your normality check will come into play. It would not have been normal distribution, then it would have gone with a Wilcoxon sign prime test, then it would have given you some results.
When we have a large data set, how can we pull that? Now we have, in these examples, we have small data sets. The data set is big. We need to import.
We can import the data set. That option is there. I've not shown you till. I think today's session we are creating and then solving. Tomorrow's session, because tomorrow's session we have a multivariate technique coming up. We cannot afford to create data set. So I have data sets for tomorrow. I'll show you that. It's simple. You just have to open that file in the CSV format. Okay. Yeah. In fact, you can even download the data set from here. Or to upload it again, you can do that. So like for instance, now this data set you have created. Okay, now that you raised this question, I can show you. Like let's say now you have created here, correct? Now you want it in the Excel. You want to get it out from the JASP system. What you can do is just go. Okay. Export data. And you can save it wherever you want to. Let's say here. And then see it comes as CSV. While going back, let's say I just save this. Say sales. Just put sales. So it is exported. I close it. I'll save this file. Dependent sample. Anywhere I save one, that's it. Okay. Okay. Let's say the one which I saved that file, I want to reopen it here. That CSV file. You can do that. Where did I? In this I saved, no? So in this, I saved that file. Where did it go?
So it's on the desktop.
In desktop. Okay. Sales. It comes back. The one so you saw. See, in JASP, it doesn't accept Excel file. Surprisingly, it accepts SPSS file, SAV file, and CSV file. So if at all you have an Excel file, what you can do is you can save it as a CSV file in Excel, and then you can import it. Okay. Pretty simple. Comma separated value file, only things. Okay. Right. So we have done with the t-test now. Okay. I just to have a quick tip, I had, of course, some of you might have seen this video. But now I'll just put it so that we have a quick.
When you have one group and want to compare its mean to a known value,
a one sample t-test in JASP is what you'll pursue.
Dependent groups, their means we compare
to see if a difference is truly there.
Paired samples track change in the very same set.
Before and after, a difference will vet.
Okay. So I'm closing this t-test session by this. Now we have the next one that we're going to have called the chi-square test. Okay, so chi-square tests are basically dealing with categorical variables. Okay, so under this chi-square test of categorical variables, I have two tests which we will be looking at. One is the test of independence, and the other is goodness of fit test. Most often, for all practical reasons, we make use of under chi-square, we make use of the test of independence. So we'll start with the test of independence problem. So you can go to the next problem sheet, okay, or session on chi-square test. Anybody here from the medical background? Okay. Then just thought another. Okay, so let's look at different context. Question number 3 under that set of session on chi-square test, right? Please look at question number 3. Okay. The results of a recent study regarding smoking. Okay. And 3 types of illness are shown in the following table. Are you on the same page? Okay. So illness, there are 3 types of illness they are pointed out called emphysema, heart problem, and cancer. Okay. And then they have also given the demographic information based on their behavior. Either they are smokers or non-smokers. Okay. So how many variables are there here? How many variables are there?
3.
6.
Wow.
2.
I can take ABC now.
2.
There are two variables, one indicating illness and another indicating whether they smoke or not. Okay, we are looking at, okay, what is it we are looking at? We are interested in determining whether or not illness is independent of smoking. So illness is independent of smoking. Okay, that is what we are going to check with this data set. Now, of course, the chi-square test is less rigorous compared to the t-test. Okay, because of the very nature that it is a categorical variable. But I must tell you that this is also a vent for writing stories. Okay, and I'll show you how. Like in this particular example, what can make it an engaging story, right? So first, we have to create this data set. What is the sample size? Sample size?
300. Oh, 300.
Sample size is 300. So that means we have to have a sample size of 300 and there are two variables, one indicating illness and the other indicating smoking or not smoking. So smoking, we can keep as variable as smoking and then we will write there are two categories, non-smokers, smokers. Okay.
3 columns and 300 rows.
Huh?
3 columns and 300 rows.
Not 3 columns, 2 columns.
Smoking.
Disease we will not take as a column.
Huh?
Disease we will not take as a column.
Which one?
Smoking is a the type of disease is not taken.
That is what illness has categories, 3 categories. Illness has 3 categories, emphysema, heart problem, cancer. Smoking has 2 categories, non-smokers and smokers. Okay.
When we are putting in the data, sir, that's what I'm.
Okay. We'll come to that when we are there. So what we'll do, just go to, okay, I'll close this. I'm going to save this file. Okay. Okay. Yeah. So new data. New data. Of course, you can resize the data. Let me have how many? 300 rows. So 300 rows. Resize. Okay. Let me start with what is the first one? Let's say illness. So I'll write illness. Now, which is easier for me? Okay, now should I start with illness? See, the whole point here is that you have to maintain a sequence. Okay, you can choose any of the variable, but ensure that you are maintaining a sequence. Flow. The flow here comes as an important thing because otherwise you may have wrong combinations. Okay. So be consistent. If you have chosen one, go according to that. Okay. Like for instance, if I'm starting with illness, the emphysema should be plotted 80 times. Okay. Then what happens is, like when you're creating the new variable, right? You need to have a split of non-smokers this because emphysema you would have covered the first 80 rows. Then that non-smokers 20 you should be there and then this. So you need to just follow that sequence. That's it. That means if I'm going row wise, please follow row wise. If you're column wise, then column because that will affect your second variable creation. Okay, that's why I'm just indicating that. So let's take illness. Let's take the row wise. We start with illness. Okay. This is a categorical variable, so nominal scale. I will use compute with R code. Here, C, yes, okay, now you're getting that. So C, rep, C bracket, rep. Then which? First, okay, emphysema. Emphysema.
Within quote.
Within quotes, yes. Within quotes, emphysema. Emphysema 80. You have to see how many total emphysema are there. You want all repetitions of emphysema together. So 80 it is. And close this. Then comma, rep, heart problem. So you don't switch over to different heart problem next to this next category, heart problem. Heart problem. If you want to give space also, it's okay. You can give space in between heart and problem. Heart problem, comma, 150. Bracket of this rep closes, comma, then rep, cancer. Cancer, comma, 70. Close for this rep. Again, another close for C. Okay. Compute column. It has come. Check it out. Please note emphysema gets repeated that way. Okay. Clear? So 300 spaces are done. See, you could have done this in Excel also. In Excel, you would have done emphysema and then autofill. If you're expert in that, it's boring. Dragging also, right? For me, that is the boring thing to do. Dragging, drawing, all those I don't like. Okay. So, and it's a reset my just take reset it. It's 300 and reset reset one. One second. Okay, now we go to the next one. Now next one you need to be careful. Yes. That's why I was doing be consistent. Go in that flow. Don't think vertical now. This is why I was just telling you to be careful. See, now you have got the outer part. Now inner cells you have to do separately. Cut. So that means there should be 6 reps. There should be six reps. Okay, that's what I was pointing at. So plus, and then here what do you have? So we take this variable as smoking.
Yes, sir.
No, not yes or no. I'm sticking to the same thing.
Sir, you need to repeat that dialogue. We'll not follow SPSS. Every time every time I mention something which is equivalent to SPSS, you immediately said that. Now somebody else has said that same thing. This yes, no, 1-0 is coming from SPSS.
Okay. The unit has said on behalf of me, right? Huh? In SPSS, this doesn't have problem. Categorical variable doesn't have problem. Okay. SPSS have problem with all those where you are grouping variables and other things, it has a problem. This categorical variable is harmless. Okay, smoking, enter. And this has to be again categorical, so nominal scale. Compute with R code. Just here, only thing is that you will have 6 reps and you have to follow row wise. Because we have followed earlier row wise only. Right? So you need to follow it row wise here. So C, open rep. You start with non-smokers. Yeah, I'm following what is there in the question. How many times? 20 times, because we are following one by one across the row. Okay. Non-smokers, 20, comma, again rep, smokers, comma, 60. Second rep close, comma, rep, third rep open. Now what? Again non-smokers. Go to the second row of that. So non-smokers,
70.
ensure that you don't make any spelling mistakes. Otherwise, there will be a twist in the tail. Because that is something which I expect, human error can be expected here. Clear? Non-smokers. So if you feel that you are prone to mistakes, write less.
Copy paste.
Copy paste also you can do. Yes. Comma. 70. Yeah. Comma. Rep. See, of course, if you make mistake, you can always correct it. That is good thing about coding. Okay, you don't have to worry too much about that. We realize where is the mistake and we can change it here itself. No? Rep. Smokers 80. Comma. Rep. I'm just continuing. Cancer. Comma 30.
Why cancer?
देखा मेरा दिमाग घूम गया तो ये गड़बड़ हो गया ना कहाँ से आ गया वो कैंसर कहाँ से है हाँ वही everyone is awake, that's what is the indication. Okay, everyone is awake. They pointed out my mistake, no?
rep
Non-smoker,
non-smokers.
30, smoker 40.
Comma, 30. But you will feel that this is worth the effort compared to calculating this the part is very huge. Smokers.
What's it?
Okay.
And one more.
Yes, close. Yes, compute column. Done. Okay. Right. So we have the data set ready. So you can go to analysis. Now, because it's a categorical data, there is a separate section for this called frequencies. Okay. You can see frequencies. So just click on these frequencies. Now, what did the table look like? It was a cross table. It was a cross table. That means it's a cross table test, or we also call it as contingency table test. So chi-square test of independence is always also called as contingency table test. So contingency tables, you can pick up that contingency tables. Contingency tables. I think after this we will break for lunch. I think we're already 15 minutes past that. So we'll take this illness.
Already made that contingency.
Frequency में जाइए.
India under the frequencies.
Analyze first. And then get second. So frequency में जाइए. Frequency. Second.
So you can say illness in one of them and smoking in another. So have you got the table? What have you reproduced it correctly?
Yeah.
Seems to be replaced correctly.
Yes.
Okay, 20/60 emphysema, heart problem 70/80, cancer 30/40. The moment you put this, you got the test result. Chi-square test, it is significant. The chi-square test is significant. Okay. Okay, now I was telling you, right, I have 3 minutes, so we'll break exactly at once. Okay. I was telling you the story, what you can put. Now, right now, it doesn't look like a great story. It only tells you that smoking and this illness are related. Right? Your p-value is saying that smoking and illness are related. They are dependent on each other. Okay, so null hypothesis is definitely rejected. Okay. This is a clear indication of the third perspective, which I was saying, no bias perspective. Here there is already a bias. It's clearly evident here that there are some diseases based on smoking. Okay, at least there are some diseases based on smoking. Now, what is the story which we can tell? Okay, the story is interesting when you plot something on this, right? So, I think options. Let's look at statistics. Does it have any option of anything? Okay, first of all, let's look at the cells. Now, in the cells, under this statistic, after statistic, there is something called cells. In the cells, you see observed is checked. Okay.
अरे
Sir.
उड़ गया क्या?
Right. Sir, right.
Right side, sir.
हाँ
नहीं, एकदम right side.
Sir, look like exactly right side.
हाँ okay sorry right. So observed has been checked, that is the observed frequency whatever we had recorded. But now we are calculating something called expected. So we have this expected also you can check. The storytelling comes from here. What is the storytelling which we are going to have? You see, for each of the intersection cells, that is the observed frequency, okay, it
Expected is given.
see that margin show totals you cancel that. The margin show totals you cancel it because otherwise it might confuse you. Just have this. That margin show totals I have cancelled it in the cells section. Margin show totals was there. No, I unchecked it so that I don't get disturbed by the total thing. So I am only looking at this. Now the story is like this. Okay. See, all right, I got a significance. That means null hypothesis is rejected, all right, but so what? Now, if you look at this, cancer and non-smokers. Observed is 30, but expected is 28. Okay. So what does it mean? Okay. Let me give a story here to make this understandable. See, like in this camera mall, there is a Momo stall there. Okay. Now, generally for 70 rupees, he gives 8 momos. Okay. That was expected. But one day, for some reason, I don't know, he was very much kind to me. He gave me 10 momos. Okay. So obviously, I am delighted. I had a positive vibe. That means I got more than expected. I got more than expected. Generally, people are happy. Okay. If it's a positive thing, okay. If you get more lashes than expected, then you feel unhappy. Right. But this was a positive thing. Okay. That means there is a positive vibe. No. Keep that in mind that anytime anything which is observed is beyond your expectation, it's a positive relationship. Now, here is a case that the cancer observation is 30, but expected is 28. That means it has surpassed the expectation. That means there is a positive relationship between non-smokers and cancer. Surprisingly, that non-smokers seems to have more orientation towards cancer than smoking. So is it a good news for smoking?
Yes.
The other diseases are also bad. Okay. It is a good news for that there, as per the sample saying that the smoking, huh?
It's about relationship, we understand.
Huh.
What's the test that statistics gives, especially for this calculation, to rule out the possibility of spurious relationship?
So that's where spurious relationship up to some extent this is taking care of. Okay. It is just telling you that unfortunately for categorical data there is nothing called effect size. Like for other things, effect size is there to take care of that. But for categorical data, it seemingly has to go with the observations only. But this is giving you an idea that there is some relationship. But sometimes, yes, if the sample specific data is there, then we can't help it.
Isn't it possible to argue that these are mere correlated happenings, not necessarily having a true relationship, which indicates
See, that's why,
possibility of spurious relationship.
that's why this particular types of tests are not considered too rigorous. Okay. But if it's an interesting relationship, something with a larger sample size, then it cannot be discounted. So here, of course, the sample size seems to be low for that section. If you have larger sample size, then things, and see, one thing is there, but it's not making too much of a difference. Okay. Like, but there is a deviation, right? Similarly, here you can see that the expected count is less for the more for. That means actually speaking, there is a negative relationship between smoking and cancer. Okay, but hold on, don't be too happy if you are belonging to smoking category. You have emphysema. Now emphysema, I don't know what is that disease. Okay, but in emphysema, it looks like it is more pertain to smoking. That means you can see that the observed count for smokers is more than expected. That means they are more likely to get emphysema. Okay. Then what about heart problem?
Non-smokers have higher.
Non-smokers have
2 out of 3. Smokers will be very happy.
okay. Maybe heart problem and cancer may not have much to do with the smoking effect. Okay. That is another way of looking at it, that only emphysema is the one which might be having some, because only that's why I asked if anybody was from medical background, they can clearly say what is emphysema.
Lung.
So lung related, it is particularly to this, that's why emphysema has that thing compared to the other diseases, which even a normal non-smoker person can also get. Okay. There is a relationship, and what type of relationship? Up to that, no, cause and effect, not cause and effect. Cause and effect is a different story. This is only about observed relationship. Yeah. So if there is additional evidence to this, this will add value.
How we got the expected?
Okay, how do you get the expected count? As a calculation, you are asking, there is a formula, row total into column total divided by grand total. Corresponding row total, if I just say, see corresponding row total 120 into 70 for cancer, I'm saying 120 into 70 divided by 300, that will give you 28. Wherever the intersection happens, corresponding row total and column total divided by grand total. That is their expected count for respective studies. Okay. Stop it. We'll continue in the next, maybe around 2:10 we can start. You can save this file.
Yeah.